For those of you who don't know me, my name is Nick Santaniello, and I'm a developer by day and game developer by night. And in my true heart of hearts, I play around with a bunch of game frameworks. One disclaimer is I'm not really like a PICO-8 expert or wunderkind, but I think I know enough just to get us started and to teach you some techniques and some resources available to using this really cool platform. I created a PICO-8 game that I'll show you in a little bit, mostly just obsessive fever dream over the course of a few months. Yeah, and I think it's a really, really unique platform. I'm not sure if you guys have had a chance to play around with it yet, but it's sort of a computer in a computer. They call it a fantasy console. It's kind of like a Commodore 64, an Atari 800, or a early PC that has programming tools built in, except it has even more focused game and art making tools. A sprite editor, a map editor, sound editor, and music editor. Before we get started, I just wanted to ask, gauge your guys' experience levels so I can better pace and tailor this workshop to you. Can you raise your hand if you have programming experience at all? Assuming pretty much everybody has programmed a little bit. And how about game development experience? Okay. And has anyone here used the processing or P5 languages or frameworks? Okay, 2 or 3. Okay, cool. Well, this is going to be, I think what you'll find with PICO-8 is that some things are super easy and other things are a little esoteric and might take some wrapping your brain around. But it's just really fun to play with. So the more you do it, you'll get better and better at it. I think a realistic expectation for today is if you create anything, it's going to be like a weird interactive art sketch, and less of Super Mario World or anything like that. But we'll look at some of the possibilities. Some of the stuff people have made with PICO-8 is truly amazing, and I can't even wrap my head around how they did it. But one really awesome thing is every piece of software with PICO-8 is open source. So you can learn from your favorite sketches, you can dissect them, and it's just a really great tool to mess around with. So I'm going to go through my little list here. Oh, I have, by the way, kind of a syllabus for today, if you want to pass that around. Just an outline of some of the topics I'm going to go through. If time's short or you're more interested in one thing or another, let me know and we can shift gears. And please don't hesitate to stop me if I'm motor mouthing and it's just way too much to absorb. But by now you've probably seen this is the PICO-8 website. Has kind of a basic rundown of what PICO-8 is. One thing that's interesting is this BBS called Carts at the top. And it's a place where you can mess around and see things people have done with the platform. There's all these categories on the top, like work in progress, jam stuff for game jams. And what's cool about these is you can basically click on any of these sketches and run an in-browser version of PICO-8 and play the cartridge. There's also a built-in forum and comments for anything you upload to the BBS. So as you can see from these sketches, they're pretty low res. PICO-8 is 128 by 128 pixels and 16 colors. It doesn't stop people from making crazy, beautiful 3D raycasting sketches or kind of dithered pixel art. And I'm going to run through some of the more impressive stuff people have done, but it's worth it if you haven't already to go through the cartridges on the BBS and just play around. Someone looks like they made a little Alex Kidd homage here. But now you've seen the website, I'm going to launch into the program itself. Let's see. So if you go ahead and start up PICO-8, and feel free to follow along. I'll keep it slow so you can, but if not, if you just want to listen, that's cool too. But when you run PICO-8, this is what you're going to see. give everyone who just joined a chance to get situated and join up. If you haven't downloaded PICO-8 already, you should have got a link with a Google Drive link that has zips for your platform. There's also these kind of copies of the outline of what we're going to go through today if you need them or want them. So once you start up PICO-8, as you can see, you're going to get like a kind of this faux command prompt. Like it's a little, like I said, a fancy console, a little sort of mini computer in a computer. So a lot of the common, if you've ever messed around in Terminal or have experience with DOS or anything, like a lot of commands used there will work here, like ls to see what's in the file system. And don't worry if this is foreign to you, or you really don't have to use it that much, but it's really fun to play around with if you want to. And of course, there's a very nice help command. One thing you'll be using a lot is Alt-Enter on your machine, or on Mac, Option-Enter will run full screen, which makes everything a lot more beautiful and bearable. So you can see there aren't that many commands here. There's mkdir for make a directory, there's reboot, there's run, cd to change directory. So as you can see, I have a few directories here. Sketches is one where I've been saving stuff, and you can basically navigate PICO-8 like a mini Linux computer. So looking at the help command again, you see, well, before I go in, there's this interesting command called install demos, which is nice because it creates a demos folder and some starter cartridges for you. PICO-8 cartridges have the P8 extension, and I'll talk more about that later, because you can also export them as PNG files, as these little cartridge images. It's pretty weird and rad. But just to give you a quick overview of all the tools on PICO-8, I'm going to breeze through this really quick, so don't worry if it's fast. We're going to jump down to each of them more in depth in a little bit. But if you hit escape, you'll be brought to this screen, which is the code editor. So this is probably the hardest part of PICO-8, just because when you type commands, the text, as you can see, is very chunky. You can't fit that many words on a screen. When it wraps, it's kind of hard to read. But you'll get used to it. And if you really want to, you can actually go into an external text editor and save the file and have it reflect in PICO-8. But this print command, which you might recognize from your various program experience, works here for a little hello world sketch. To get back to the command line, you hit escape. So you can hit escape to toggle between the code editor and the command line. And if you type run, you will run the sketch that's in your code editor. So there's our beautiful application. But before I go more into what you can do with this, I'm going to show you the rest of the features. So when you hit escape to get in the code editor, you'll notice you have a mouse cursor now. And I'll show you everything you can do in here. So down here you have kind of token counts. This will be like, each PICO-8 cartridge is limited to a certain amount of memory, so you can manage that here. Up here, it's a relatively new thing they've added. It's a tab system, so you can kind of keep code segmented into different sections. For today, I think you can just stick with one. But most importantly, on the top right are these kind of sections, different parts of the editor. Yeah. I go back. Oh wait. Yeah. So if you hit the little face up here, you get to the sprite editor, which is by far the most fun part of the PICO-8 interface. So in the top right, these are the only colors available in PICO-8. It's a really, I think, really pleasing color palette. And so you can literally just click and paint style draw 8x8 sprites. I don't know what I'm drawing here, but maybe like a sword or something, blood sword, I don't know. I'm also very bad at drawing, so 8x8 is great because it limits it to something I can polish over time. There's some basic commands here, like a fill bucket. There's a stamp tool, and basically, as you can see, each one of these 8x8 sprites is taking up a slot in memory. So that is now sprite 001. There are, You can zoom out, so you can make compound sprites. If I want to make a big planet that was 4 sprites, you can do that. Down here, these are memory banks. So there are 4 memory banks here of sprites you can load up. We're going to talk more about limitations later, but for now, you should have, this is ample space. So, feel free to draw stuff and muck around, but I'm going to move on and show you the other parts of the editor. This is the map editor, so you're kind of like, what am I looking at here? If you hold space and then click, you can kind of pan around. If you have a mouse wheel, you can also zoom out. So basically, this lets you construct maps with your sprites and then use that map in game. So, oops, that's not what I want to do. Let's see. So that may look like I just drew a blue line, but really I was painting with our beautiful new odd sprite in this map. So this is really useful if you want to lay out levels. It's actually quite large. There's quite a lot of space here. Considering each one of those little blips is basically an 8x8 sprite. If you continue looking, there's also a sound editor and a music editor. These I'm less familiar with. I'm not a music person, but they really are fun. Let's see if I can get a little more volume to play with. There's all sorts of different types of waves, and you can kind of adjust the volume at different points here. You can also click on speed. Strangely, the higher the speed value, the slower the sound effect plays. You can also set which frame to loop on and how many loops. And with this kind of toggle here, you can scroll through different sound effects. You can also, if you click this grid command, you can see literally the notes that are playing, their duration, and apply effects to them here. So if you ever look at the bottom panel right here, it's really poor on the screen, but you can see there are some contextual hints, like holding shift and click on an effect to set all. And the music editor basically lets you construct patterns of sound effects. So I only have, let's see. I only have one sound effects here. Let's see. So as you can see, all the other banks here are empty. But basically, you can construct sequences with this. You can actually use the keyboard as a sort of a analog for a keyboard. Like if I hit going back to the sound editor and going to the grid mode, I can click into panels. I'm hitting the D key right here, and there's more information on this in the README. So going back to the command line for a second, there's also something that's relatively new to PICO-8. I thought it was kind of a little much at first, but now I'm thanking my lucky stars for it. So it's called the Splore interface, short for explore. So if you type Splore, you're brought to this menu here, and you should be on Wi-Fi if you want to use this. If you came in late and don't have Wi-Fi information, it's right on the wall behind you. And there were problems with Wi-Fi earlier. Did everyone get on it okay? Maybe. Well, if you're connected, you should be able to click this update button using the keyboard and hit enter, and you'll see all these different menus. There's one for the local file system. There's favorites that you can kind of star. Brand new stuff. Featured, which is always really impressive. And it's just cool to see what people have done and what's out there. You can just click enter to see some, to favorite it, to run the cart, or whatever you want. So here's someone who's done like a 3D camera, sort of voxely island. I know. Let's see. I thought this one was also really impressive. Sort of a 3D style racer here. So to play PICO-8 games, one thing I forgot is Z and X are the kind of like the A and B button, along with the arrow keys. Let's see. And so, I mean, there's obviously hours you could spend here. Two of the very popular featured cartridges are running at the top, Celeste and Dust Child. So Celeste, which we have running on those CRTs over there, sort of kind of a twitchy Super Meat Boy-esque platformer, and you have like one sort of one double jump every time you hit the bottom, and the goal is to get higher and higher. So as you can see, like even within the constraints, people are doing really cool things, really aesthetically pleasing stuff. So yeah, I encourage you to go through Splore and favorite a bunch of cartridges and play them. Sorry? How did you download them? Yeah, so once connect to Wi-Fi, you run Splore, and there should be the first option in the menu should be Update. It's a little, it takes a little wrapping your brain around what's happening, but yes. There's new, featured, work in progress, collaboration, jam, and then a search term. You can actually search the online repository, which is really cool, and then slash for your local file system. So I don't know exactly, but I assume it's for PICO-8's a popular choice at Rhythm Dare and other game jams because you can just kind of pick up and you don't need to import sprite sheets or so I think often collaborators, especially who are working remotely, use that section. So I assume it's similar to the work in progress section, and it's a little, the categories overlap a little bit. Like for instance, collaboration seems to imply looking for someone to collaborate, and like I said, if you go to the BBS thread, like so, let's see, for what's one that looks. I don't even know what the hell this could even possibly be, 6.4.2.0. So we can click BBS thread, and that will take you to the thread for this particular, whatever the hell it could possibly be, running the browser, and there's a comment thread. So this looks like a joke thing. Please don't ban, please. But you could potentially have a discussion here or reach out to the creator. So that's what I think it would probably be useful for. With the addition of the Splore interface, I use the BBS less, but it's cool how tightly woven it is now. Show you one more, and then we'll move on here. Let's see what time it is. This is one that was done at a game jam recently that I think is pretty mind-blowing. It's called We Missed You. And I think it's about the goal is to be a deliver mail while people are not there, so they can't get it. And it's great. It's got this like 2D sort of original GTA vibe to it. And, so you get out of your car with X. Oops. Sorry, mixed you. Maybe next time. Ha ha ha. You get back in your mail truck and continue on. Yeah, it's really impressive. So what's really gonna blow your mind though is that with anything you download. So now that we if we go back to the command line by hitting escape from the Splore interface, I'm going to type CLS, which is the clear screen command. Now that cart is loaded in memory. So if I hit escape, I can actually see the code from that game. I can also look at the sprite sheets for that game. I could even edit them if I wanted to. Like say if I wanted to make the truck have, when it's going up only, be pink. I think I can do that pretty easily. Yeah. So now if I escape out and hit run, I'm going to truck's going up. I think, yeah, there's our relayed sprite. So the point is, you can edit these and you can learn from them. Here's like, for instance, the map editor, and how you'll see, again, to pan around, you hold space and click and drag, and you can use your mouse wheel. You can see all the different map data, and how developers use this varies widely. And for cartridges like this that are so elaborate and they're probably stretching the boundaries of what it can do, they probably had to employ some really creative tricks. Let me see. Looking at actually, I'm close to the code limit here. So that is the Splore interface, and let me see. Let's look at a few more here. I got this one I thought was really cool. It's called Saxophyte. You're like a jazz musician, and you've got to like survive the hard Scrabble. And like, it's just so odd. I mean, so when you hold the X button, it's shooting the tones to the beat, and I'm defending myself against these flying trumpets. Anyways, it took me a while to figure out what to do here as I got pelted by trumpets. But yeah, like looking at the code here, or the sprite sheets, you can see this developer chose to use most of the sprite banks with these giant, nice animated sprites of the protagonist. Music notes, here are the various like characters in the background. And so this developer didn't use much of the map data, just as a basic one level. So I showed you how to install demos, and two other really basic. I showed you how to hit escape and to edit the sketch that's in memory. One thing that's useful, you'll find yourself doing a lot, is typing folder. So folder will bring you to your OS's, basically the directory where you have your various sketches. So this is great if you want to move a cartridge to another machine, or you want to you're offline and you have some cartridges you downloaded and you want to plop them in here. Super useful. And you can see like these apps are tiny. Like let's see, what was one let's see, like Saxophyte, for instance. Oh, so if you want to save something in memory, you can type save in the file name. So I'm going to call this Saxy. And now going back to folder, I can see there it is, 88 kilobytes. One thing, another basic useful command is reboot, which is basically like new sketch. So if I wanted to start from scratch, just type reboot, back at the PICO-8 command prompt. So next, I'm going to show you your PICO-8 Bible. So I'm going to exit full screen with Alt-Enter. And I'm going to pull up my handy-dandy text editor. Whoa. Let's see. Read that okay. This is PICO-8 TXT. It comes with it. It's the README. It's really good, and it's basically all you need for anything. I mean, sometimes it's a little obtuse, but for the most part, this has a lot of interesting stuff that I didn't even know. I reread it, and I haven't read it since I first downloaded PICO-8, and there's a lot of great options, keyboard shortcuts. Like, it's really thoughtful. It has information about the specs of PICO-8, basic Hello World sketch, and goes through sort of like everything I just did. The file system, different command line parameters, how to take screenshots, videos, GIFs, how to share cartridges. It's really fantastic. You can export sprite sheets, export soundtracks, export HTML versions, and even like a OS level executable, which is something new and something really cool. But we're going to be looking through this side by side as we move on. Does anyone have any questions at this point? Am I going too fast or is it too slow? Okay. Well, then I'll keep on keeping on. You all right? Okay. Um, so let's look at the sprite editor and the map editor quickly, and then I'll show you some PICO-8 commands to draw stuff and make stuff move. So one thing I just wanted to note here, as you're drawing, and please don't mock my terrible things I'm drawing on the fly, is that it seemed like maybe you saw some of the map data may have looked garbled or like it wasn't real sprite data. It's because the sprite data and the map data share space. So what I mean by that is you can have more sprites if you want, or more map data, but not both. So these last two banks, 2 and 3, correspond to the map, the bottom half of this map data. So you just have to be aware as you kind of reach limits that you could overwrite accidentally some of your data. But if we stick to the top half of the map and the first 2 banks here, we should be pretty good. So let's jump right into some Lua commands and draw some stuff on the screen, why don't we? One thing I did want to highlight here is these little orbs draw a line or draw a square, like just primitive shapes. PICO-8 is the flip. You can very easily, sort of like processing, draw circles, fill them, draw lines, draw pixels. It's not as easy for. It doesn't have any built-in physics system or anything like that, which is cool. It has strengths and weaknesses. But let's look at some commands here. So now I have you might want to save the sketch. Like I have one called tester. I'll call this tester 2. Just so like any art you're drawing you can use or have multiple. One thing that we can use later. So we have some sprites and stuff to work with. Let's see.
When you zoom out, does it make pixels smaller? It just makes the sprite bigger.
Right, yeah, that's a good distinction. So as you can see by that white box in the bottom half of the screen, when I scroll my mouse wheel down, I'm widening how many sprites I'm editing, but there's no concept of zooming in PICO-8. While there is a basic camera system, the screen is always 128 by 128 pixels, and individual cells here are 8 by 8 always. But the zooming out is if you wanted to make a larger sprite, like that Saxophyte main character. So I'm trying to draw a heart here. Let's see how that works. Kind of worked. Yeah, I like that. So going back to the code editor for a sec. I already showed you the print command for creating text effects or just outputting debugging information. Similarly, there's the CLS command, just like in the command line, you can use to wipe the screen. So now every time I run, the screen is wiped. I'm going to show you some basic stuff. So this is where it could get weird and confusing quickly. So if I'm at all points steamrolling you, just yelp or raise your hand or something. There's a command called color, which takes one parameter, which corresponds to the numbers here. You can highlight them, and at the very bottom of the screen, you can see the number, which color I'm referencing. So this pink is 14. So if I type color 14, everything that gets drawn after that is going to be pink. So there's a command called, 2 commands called pget and pset. And those basically set a pixel on the screen. So I'm zooming along with the README here so you can see the description. And I do this all the time, and you will be too. So, okay, pset x, y, c. that means we can draw at XY with this color. So if you look at, so say, remember the screen is, well, let's try 0, 0 first, and color, I don't know, 9. So you can't see it very well, but at the top left of the screen there is an orange dot on the top left of the H. That's 0, 0. The origin is the top left in this framework. We know the screen is 128 by 128, so 64 by 64 is the center of the screen. So this will draw a nice little orange dot right in the middle of the screen. So some useful basic stuff. So there's also pget. So if you want to sense the color on the screen for use in your collision detection or game mechanics, there's pget as well. So let's print out pget at 64, 64. And I will say 9 because the color at 64, 64 is 9. So this is very boring, but drawing particle pixels is really useful if you want to create explosion effects or bullets. And this is trying to get you familiar with the basics of this drawing system. But more exciting than that are the circle, fill, line, rect, and rect fill commands. So let's take a look at those here in the README. Basically, PICO-8 has these helpers to draw primitive shapes. So, let me turn. Yeah. Draw a circle or filled circle at XY with radius R. So let's try 0, 0 again with radius 20. So as you can see, 0, 0 probably refers to the center of the circle, which is why it's only a quarter on screen. So let's put that at the middle of the screen. Beautiful. Circ fill, similarly, I'm putting it just 30, 30, so the top left of the screen somewhere. I'll give it a radius of 40. Nice. So, like other frameworks of this type, PICO-8 is kind of uses a painter's model. So the reason the filled circle is on top of the hollow circle is because it comes after it in the code. So say if I turned the first circle, I'm going to change the color in there so we can distinguish between them here. Whoops. This is an important lesson. You'll see this a lot. When something's wrong in your code, PICO-8 will tell you. Sometimes error messages are helpful, other times they aren't. But syntax error line 8 should be pretty obvious what I did wrong. I hit mashed tilde, so that line threw an error. But as you can see, depending on which in the draw cycle, which command comes, new draw calls will be drawn on top of the canvas. So if you want to change which is on top, you just have to change the order of these. So you can also, as you can see, we've got lines, rectangles, and these are super useful helpers. I think in that Celeste sketch, for instance, one important thing is Command S will quick save once you've written save in the command line with a file name. Super useful. I encourage you like reflexively hit that often. But I've saved my sketch. I'm going to go back into I think in the directory I gave you guys stuff. I have Celeste in here. What's Celeste? So like that background pattern, those floating rectangles, that's just rect fill. That's nothing special. So don't discount these really boring seeming functions. Also the snowflakes or the kind of ash in the foreground, it's probably rect fill or p set. So I'm gonna get back to my tester sketch. Before I'm going to switch something up. So, if you've ever used processing or similar frameworks, there's two built-in functions in PICO-8. I should also mention this language we're using is not called PICO-8. It's called Lua, L-U-A. It's a scripting language that looks like JavaScript or ActionScript. So it's going to look similar to if you've done JavaScript, but it's slightly different. It has some foibles, but we'll tackle those. But there's two built-in functions in PICO-8: update and draw. So one thing you may have noticed in this sketch is that command prompt was always there. That's because the sketch was ending. Having an update function means that every 60th of a second, it's going to run and keep the application alive. So same thing with draw. So update's where you update your game logic, and draw is where you draw basically the results of that logic. And this will make more sense as we move on. But I just wanted to bring that up because that command prompt was bothering me. So now, as you can see, our sketch doesn't have the ugly command prompt. It's running right now and waiting for logic that doesn't exist. So if you look through the README on your own time, there's so much more. You can switch palettes, colors. You can fill areas. But I'm gonna focus on just some of what I think are the core functions. One really fun one lets you draw the sprites that we drew here on screen. So say we want to draw this beautiful heart. We can see this is sprite number 2 down here. So the command for this is SPR for sprite. Go to the README. So it takes, the first argument is which sprite, 2 is the heart, at which x and y. Let's put it on the bottom right of the screen. So maybe 70, 70. And you can see with height, flip x, flip y. Those are optional. These are helpers if you want to flip the sprite. And with height means, like you were saying, Mark, if you wanted to draw these 4, you could set a width and height. So you're not just drawing sprite 2, you're drawing a matrix of sprites starting at sprite 2 in the top left. So sprite, if we just do this, there's our heart. Let's get out of there. I want maybe like a little, oops, that's going to be off screen. Does my heart have a lopsided? I want to fix that. It's bothering me. Yep. Yes. Full screen the PICO-8. Is everyone doing all right? Any questions or is this? Yeah. Yeah, I was going for realism. I'm going to clean up some of this sketch here, printing and stuff. One function I forgot to mention is called cursor, which lets you move the text around. So say we wanted text starting in the middle of the screen. Again, I could use 64, 64, and then say this starts. Actually, that's going to scroll right off the screen. How about my stand? Ooh, they must have added this. If you hold, you'll notice PICO-8 editor, everything is caps, which makes at least those kind of type errors, case errors, something a thing of the past. But if you hold shift and hit certain keys, you have these sort of helper text glyphs. Whoa, this is really cool. Anyways, let's see if that works. So we only see 2 of them because they're getting drawn below the circle. But you can see they start probably right in the middle of the screen at 64. 64. There are two sets of commands: fget, fset, mget, mset, for checking map tiles, checking flags. But I think I'm gonna skip those for later, once we have some map data to play with. But one thing you can do is sfx command to play your various sound effects in the bank. So I must have started a new sketch here, and I'll have a beautiful sound effect. But let's create one. Wow, this is the worst sound effect ever. Okay, I'm gonna do something different. Okay. At least that's a little less offensive. Okay, I made it offensive. Let's start again. Okay, we're just gonna go with that right now. So that's in bank 3. So by just hitting SFX3, can anyone tell me what something bad is going to happen when I run this? Do you know what it is? Yes, it's going to run every frame. So it's probably actually going to... Actually, we might not hear anything because I think the beginning of the sound effect is an empty space. So it might keep restarting itself. Yeah. So to fix that, I'm going to move this out of the draw loop and just put it at the very top. Gorgeous. There's also the music command, which will play the various like compositions you create. So the way this works is 0, 0 is going to play, then 1's going to play, then 2's going to play. So I could have my first sound effect here, followed by my second sound effect, followed by my third and my first playing at the same time. So now, let's see. Oof. This is my beautiful composition. I knew I should have asked Mark to come and do the music part. But I can call that the same way. I won't subject us to that though again. So let's talk about the map for a bit. I'm going to create a little bit of a map terrain here for us. So again, you can hold space and click around. And I believe this is one screen right here. Let's go. Oops. Before I draw anything, let's create some tiles we can use. This tile here with the X, by the way, on the left is delete. So let's see. I'm going to create some like kind of girder crates. I'll create some like dirt and grass tiles, something like that. Maybe some clouds. Command Z works for undo. Let's see. I'm also going to have just a generic sky tile. Maybe. How about like a shrubbery? Shrubbery sounds pretty good. Like berries or something. It looks kind of like a Christmas tree. Let me see. Thinking of some like caution tape blocks or something like that. Oh, it looks more like Charlie Brown. Okay, so now we've got like a lot to play with. So going back to the map here, try and let me just paint the whole thing with sky tile to start. So we have that base. Let's see. Why did this not get painted? Okay. 16. So this is the bottom of one screen here. I'm going to put like draw some tiles. Oh, one thing we're noticing is that black is black. There are ways to swap out colors with transparency, but for now I'm just going to paint sky in here. Same thing with the cloud. Oh, happy accidents. Okay. I'm also going to make a generic brown tile for underground. Dirt. You can copy and paste tiles too. There's also keyboard commands for flipping them. Okay. You know what? Actually, I'm just going to go pure. So now, let's see. Let me edit. Okay, so here's the beginnings of what could potentially be a level or something interesting. I'm going to show you how to draw it on the screen. So the command we want is called map. map, cell X, cell Y, SX, SY, cell width, cell height, layer. So there's a lot of options here. But at its most basic, and sometimes I still get this wrong. This example here helps the bottom. Draws a 4x2 block of cells starting from 0, 0 in the map to the screen at 2020. So we want to draw, our map starts at 0, 0. We want to start drawing at 0, 0. And we want, well, let's just see what happens when we draw 2 cells by 2 cells. Okay, I'm going to get rid of our circles temporarily because they're getting in the way. Well, we don't see anything. That's weird. 2020, 4, 2. Oh, of course, because the clear screen command's after the map. Alright, clean this up a bit. Okay, so those are the first 2 cells. Let's fill the whole screen then. Okay, getting closer. Okay, these hearts with the old transparency really bother me. So I'm going to change the heart. Okay, that's a little better. What's going on with the 2 black scenes up here? Okay. Alright, so here's what our sketch looks like now. It's gorgeous, I know. So that's how you draw map data on the screen. It's let me go back to look at. So it's map, starting position on where you want to draw, then the starting position of your map, and then how many 8x8 cells. Yeah. The scale is, it'll take some time. I find the map actually editor, I constantly get lost with how big is this? How many screens am I looking at? Like you can see with our sketch, I stopped drawing because I, for some reason, got the screen to here.
How many cells is this map editor?
Good question. Let's find out. So for anything, I like to, it is 128 by 32 cells. And if you want, like I said earlier, you can double that by taking the second half of the sprite bank. So going back to the editor, basically the map is as big as these two. These, like 2 of these rows. And if you want, you can double that by cannibalizing these 2 banks. It's a bit confusing. It's easier to find when you're like when you fill up your banks. Let me see. So I'm going to go into some Lua stuff, like just some basic programming things, and then using that, we're going to make things move and respond to button presses and be a little more dynamic than this. Because right now, all we can do is draw to a screen, but we've done pretty well. We can draw shapes, lines, text, sprites we've drawn, and maps. Does anyone have a question or anything, or take this moment to reflect? Okay. So the README has a pretty good pretty good little primer on Lua. It's also important to note this is not full Lua with the standard Lua library. It's kind of a stripped down version. But to comment, you use 2 dashes. So you'll see that in a lot of code, and it will automatically gray out if you leave comments to yourself or to others looking at your code. Here's where I draw the map. You can see doing double dashes automatically fades the color. The types in Lua are numbers, strings, booleans, and tables. So there's some real technical info here about what happens when you have, working with non-integers, and there's a lot of quirks, but you shouldn't have to mess with this until you run into a problem, at which point you'll come to the README like very confused. But I just wanted to show you some general programming concepts, how they look in Lua. So if you've ever used an if statement in JavaScript or processing or whatever, this is how it looks in Lua. So if, let's say, if game over equals true, then end to do, end the game here, and then end. So instead of using curly brackets to close functions, you use a word. In the case of if, it's then, and then end. Same thing with functions. You see the draw function and the update function both end with end and don't need an opening curly brace. So this actually reminds me of BASIC, but it's the same logic as any scripting language or programming language you've used before. Loops. Loops are really, really crucial in Lua because the general way you'll be managing things is you'll create objects called tables in Lua, add them to a list, and then cycle through everything and tell each thing to update itself or move itself. And that's done for x, let's see, for x equals 1, 5, means starting at 1 until increase x till it's 5. The word we use here is do. It may seem annoying to have a different word for each type of function, but there's really only 2 or 3, then or do. So for x 1, 5, do, let's print hi, space, and end. So now that's going to print, oops, error on line 13. Hi, 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 hi. Very useful. Not for that, but other things, of course. Let's see. One, local variables. So if you've used JavaScript, sometimes you keep, you use a variable in a loop to keep track of something, but it's not something you want to expose elsewhere. You use the word local. It's the equivalent of var in JavaScript. Don't worry too much about this. Just know that, like, in general, you might have a global variable at the top of your game, be like manage the number of lives left. Lives left equals 3. This is a global variable. This is how I would manage that variable if I want everything in the program to be able to access it. It's always going to be the same. Local is something you use in a function just to keep it restricted to that scope. I think if you called this local up here, it would still be, in essence, a global variable. But just something to know if you see. Does that make sense to everybody? Like a local variable versus a global variable? If not, I mean, it's crucial for game dev, but for art and interactive sketches, it's not something you really probably won't need to focus on. If in doubt, use local, I'd say, unless it's something very clearly you want to have access to across the whole sketch. Tables is something that's kind of a unique concept to Lua. A table is like a JavaScript object or an array. It's basically one structure that can be anything, and it's designated with curly brackets. So it's a list of things. I think you'll find it most useful in this sort of context. You'll create an object with an empty table, and then you can populate key value pairs using dot notation. So you can kind of, it's also useful for basically, you're going to add items to tables and then iterate with a loop through a table to move things around. This is going to become more clear when we actually do it, but it's just important to know that PICO-8 and Lua call them tables, and they're kind of a one-size-fits-all array and object. There are some methods for going through them, like for each, pairs, all. So in this example, add t, meaning add to this table that we've created, it's 11, 12, 13, add the number 14, then add the word hi. And then for v in all t, do print v. So just print out every element, and you can see the list is going to be 11, 12, 13, 14, hi. And you can also, there are different ways to access elements in the list, but for the most part, you're going to be adding things to a table and deleting things from tables. There's also I think the command is del. Make sure it's in here. Yeah. So add a value to a table or delete a table. Delete a value from a table. There's also a bunch of math helpers which are great for games and for drawing, like sine, cosine, etc. Let's see. Why is my keyboard has abandoned me? Let's see. I can't type anything. That's not good. Let me see if I can quit this. No. Sorry, a little technical difficulty here. Okay. I'm back. So I lost some stuff because I force quit in panic, but it's okay because weren't going to use any of that anyways. Here's some of the math stuff. Cosine, sine, square root, absolute value. The most interesting one you'll probably love to use is R&D to get a random number. So yeah, let's mess with that. Let's do something dynamic here. So I'm going to start from scratch. Let's say, oops, language. Function draw. Function update. There's also one more helper function, init. I find you don't really need to use it because you can just run stuff at the top of the sketch, but it's useful to know and to have. So let's use some of these new skills. So let's create a loop. Let's go back here. Let's say, let's draw like 20 random colored circles or something, strange like that. Let's make a loop. So from x0 to 20, let's do circle at 2020 with radius 30. So that's going to just draw, so I forgot to put my clear function. That just draws 20 circles in the same place. So why don't we, so random is going to produce a random number between 0 and the number you choose. So let's say random 128. So anywhere from 0 to 128 on the x-axis, we're going to draw a circle. Let's do the same for the y-axis. And then radius, let's do a random number between 0 and, I don't know, 50. Let's see what that does. Oh my. So I didn't even anticipate that. That's because we put this in the draw loop, so it's re-randomizing our circles every frame. That's cool. Let's also like choose a different color each time. So looking back at the color index, we want to avoid 0 and 1. They're dark, or these are brown. Let's start at like 7 through 15. So I'm going to say color is 7 plus a random number between 0 and 8. One thing to note is if you want an integer from a random value, it might produce 6.2. It's not, you use the floor command that rounds it down. So I guess it should be 9. Let's see. Expected close parentheses to close your opening parentheses at line 16 in your circle. So I must have left. Yeah, here we go. Missed the closing parentheses. All right, now we're starting to get somewhere. Not feeling this? No? All right. So one really rad function is called button, BTN. And this is how you read input. So there are two big functions, button and button P. Button just gets the state for a button's pressed down. So they've added a lot of different helpers so you can have multiple players, but for now let's just focus on one. So the buttons here from 0 to 5 are left, right, up, down, button 1, button 2. So by checking for button 0, we can check if the left key is being pressed. Button 1, if the right button is being pressed, etc. And here are the default. Default. That's all right. No foul. So button P checks if a button's pressed. So this is useful for, you don't want, if you've ever done game development, you know, like holding a button, you just want it to fire once until the player lets go and presses again. But sometimes you don't. Sometimes you want to check the buttons held down. So these are two really simple functions for doing that. So let's do something with it. So let's draw our circle medley only if the Z button is pressed. So Z, you'll remember, is button 1 for player 1. So 0, 1, 2. Okay, so that corresponds to button 4. If button 4, then run through our loop. I'm going to add another end in here. So they're visual. They're just to keep it organized for myself. It's really hard because they're only one character because there's no characters to spare, but I find it's a good habit to use them. So now nothing happens unless I hit Z, which point we get our rad circle sketch. Okay. Let's see. Does anyone have any questions or thoughts, or is this like, yeah? Yeah, so that's a function called CLS, right here, the first line in draw. So that's so every frame, the screen's being wiped. If I got rid of it, we can like hold down the button to draw and not erase, which is also a pretty cool effect. Yeah, so by putting it in the draw function, it's telling every frame start from a blank canvas and then redraw everything instantaneously based on variables we've set. So later, this is really useful for if you have a player character and you want to store their position, and we're gonna get there. Is there any other questions or thoughts? Or oh, you know what? That's a good point. I should. I generally do that in updates. So what you would usually do is say like, if this were a player, I'd check for input, set their velocity values, and then in draw, actually draw them at their updated values. So I mean, one thing I could do is say like, if button 4, then Circle Mania is true, and then down here in draw, say if Circle Mania, then yeah, so that should work. Yeah, good point. It's just very much better practice to handle all logic in update, and then draw just draws based on variables that are being set in update.
When does update go inside the particularly draw?
I think it just runs right beforehand. I don't know about the time scale, or it's in the README. It's probably more detailed information. It does seem like kind of you might be able to get away with doing them just in one. This might almost be a peace of mind thing. I don't know. I'm just worried that certain functions won't run in update. Like actually, I don't think you can run a draw function in update. Let's try. I'm going to try and make a giant rectangle that covers the whole screen. Yeah, that didn't do anything. Oh wait, maybe it did. Let's go. Oh no, it worked. Explore that for a second though. Look at the README. What did you find? Was it related? Oh, here we go. Update called once per update at 30 frames per second. Draw called once per visible frame. What's that?
If you scroll down a little more, there's a 60 FPS version.
I find the nice thing about PICO-8 is generally it can run very, very smoothly on even minimal machines. If you guys saw the little TVs over on the picnic table we can play with later, I have a Raspberry Pi set up running Pico and like a mini Windows PC, and you could do chip computer, you could do Raspberry Pi Zero, Intel Compute Stick. It's really a nice lean platform. Let's try a few like. So I'm going to do like a little, let's see. I'll show you like one of the math functions, and then we'll build a player and move a player around with input. So I'm going to save this. I want a new sketch, so I'm going to hit reboot. Let's see. So one technique you'll use a lot is timers, and there are edge cases and things you have to learn, worry about, like a number getting too large. But for the most part, by increasing a variable, you can kind of use it in math functions. You can use it to kind of trigger events. So to do, you can, as in other programming languages, increase a variable with the plus equal sign. So this is saying every 30th of a second, increase timer by 0.01. I'm also going to store a value that's cosine of timer. So cosine sign returning a value between 1 and -1. In the draw function, I'm going to clear the screen every frame. And let's see. I'm going to draw just a little line in the corner of the screen. So this is what I'm working with now. It's just this white vertical line. Now, what I know, there's a method to this, I think. So I'm going to make a simple loop to draw this line several times along the x-axis. So there we go. This could be, So what I'm doing is I'm using the x variable in this loop to say, just have the start of the line value be further and further along to the right. So now I've got 8 different lines kind of spread out. If I do another loop, I can draw them along the y-axis to sort of draw 8 rows of these 8 lines. So let's see. Why did that do that? I'm going to spread them out by 16 pixels, or draw them 16 pixels width, or spread them out by 16 pixels. I'm drawing them at 14 pixels. I know this is a little confusing the way I have it right now, but hopefully this will make sense. So there's my nice little grid of lines. So now we can use I'm going to use our sine function to add a little variability here. I'm going to change like the endpoint of each line. Whoa. That is not kind of what I was thinking about doing. So, I mean, as you can see, there's tons of great, like, playing around. Oh, this is why. You can do with these math functions and drawing and in loops. I know it was a little unclear what exactly I was doing, but basically I'm adding the variable given by the cosine function multiplied by 8, and then adding it to the front of the line in the y-axis and subtracting it from the end to have this kind of sort of seesaw effect. I think PICO-8 is really good for this kind of stuff, and half the time you get some happy weird accent you really like. But I basically just wanted to show cosine in a function. But I want to move on to moving like a player around, or how you might do that. So let me. Did you guys want to look at this a little more, or ask questions about? Yeah, definitely. Okay. Yeah, yeah. John just suggested maybe like a bathroom break or intermission here. Does that sound good for anybody? Or maybe enjoy some stale popcorn, the finest. And if you want, play with the machines up there. I've got a few like sketches running. Yes, yes, sure thing. It might be hard to read because this is probably the line here. I'm gonna put a return here so you can see. Actually, that may not run the way I did it, but I just did it right there so you can see it. I don't know if there's a word wrap in this editor. Yeah, this is... Okay. Maybe I'll drop this in the Google Drive while we take a little bathroom break. So I can do that by I'll bring the code back in a sec too. I typed folder. Here's sketches saved. Let's see. Put it in the drive folder here. Yeah, so if you access that link, it'll be there. And you can drop it in your PICO-8 again by hitting by typing folder and then just dropping it in that directory. So here's that code again. Yeah, so maybe we'll start again in like just I don't know, Johnny, what do you think? 5 minutes, 10 minutes? Okay, so at like 7:40. And if you want to talk to me about anything in the meantime, like I'm here. Okay, yes, thanks. Yeah. Mm-hmm. Okay. You want to do it at the end, or? Oh my God. That's like the best thing anyone ever has done. I'll abstain if it means someone can eat. I think my buddy Walt might have brought some snacks. How's it going?
Good, man.
Is this interesting at all to you, or?
I made this guy.
You did this really right now?
Yeah.
Fuck.
I mean, two things that I don't know if we're gonna cover, but like sprite animations would be cool.
Yeah.
It's not evident like how to do this in sprite editor.
Right. So you're basically switching between each frame. You're switching to a different.
Yeah. I figured that was the thing, and also collision detection, which is probably in here.
Yeah, actually, it's not because it's and there are different ways to do it, and the way I do it is ugly. But I'm glad. So it seems like I'm going kind of slow, at least for you.
I also was kind of following you, but since I've done processing before,
Okay, yeah,
I was
you jump right in.
I also found this. There's code here for character movements, which is just in the read.
Oh.
So like this.
Yes,
so
X+1. Yeah.
That's just I dropped that code in.
Yeah, that's what I was about to do next. I was worried where I was going too fast actually, but I guess I'm going kind of slow.
I think it depends on what people are.
Yeah.
Do,
Let's see.
But yeah, having some processing-based knowledge is helpful.
Yeah.
Move stuff around.
Yeah. Let's see.
Hey,
Yo,
man,
how's
what's
it
going
going,
on?
man? Thanks for coming.
Brought my pocket
Oh,
chip.
nice.
Can you run it like as you're running PICO-8 on the computer, or
Run,
Cool, if I
run.
like run what I'm editing, or is that just too self-contained?
You mean like run it on that
Right.
here?
Yeah.
If there is, I don't know how. But then again, I haven't really explored with the pocket chip
Yeah.
hardly at all. Oh my God! Look at he brought it. That's great. I want to take a picture of that. I'll grab my phone. So not too. I mean, for you, it's probably pretty remedial, but yeah.
And it's interesting getting in the mind space of like redrawing every frame.
Yeah.
Like clearing the canvas.
Yeah. It's refreshing yet like frustrating at times.
Wait, what are the parameters on this line function? Is this
Okay,
start,
yeah,
start,
yeah.
Blank, blank?
It's start, end, end.
Right.
Yeah.
Oh, okay, so I'm just starting and ending.
Right. I should have explained that better. You know why? Because I had the finish thing. But what I usually like to do is like print out the code and like highlight how I did it. But I can't because that line where I started with is not there anymore. Like I started with line X, X, Y, 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 and I'm like, oh, maybe I'll add some. Maybe I'll multiply some.
Right.
Let me kill this mic real quick. Thanks, man. You know, that was just asked of
Just pop an SD card and it's like the same thing.
Oh yeah, I might need a little bite of that. I should have eaten some. Let me see. You know, there are tools for doing that. I've never done it. Let's take a look. I mean, if you're like a amazing pixel and you've got a tool that you like to do it and you have stuff ready, maybe. But I think probably not. Like dealing with how it handles colors that aren't in the palette and like. But there's some resources for stuff like that. I'll share. Let me look that up right now.
Oh my god. We talked that happens. We have to get some things around. You know what I'm talking about. That could be a problem. I know.
So to answer your question, this repo has a lot of interesting resources called Awesome PICO-8. I haven't used anything on here, but it looks like it has things if you want to import, you know, you want to use your text editor, if you want to like use an external tool for art. I don't think you need to use anything. This might be interesting, this music tracker tutorial. Yeah. Yeah, I can definitely see that.
But the question is, do we need someone there?
You know, I'm not sure. It seems like maybe. I definitely, when I was writing a game, it would crash sometimes. This was very early. This was like 3 years ago. So I stopped doing it because I got scared, but now I might be more confident using an external editor. Yeah, there's also a really cool like culture around PICO-8. There's like PICO-8 zines. Like there's a PICO-8 cafe in Japan apparently.
Where?
In Japan.
Yeah, where?
I don't know, Tokyo. Because the creator is currently living there, I believe.
Of course. Amazing.
Yeah. Zines. Okay. I'm going to start up again in a sec. Let's see this real quick. This looks interesting. I kind of want to do this. This is a tutorial of how to make a space shooter in 16 GIFs. That's pretty rad. One thing that's really cool is, see the cartridge here? You can save a PICO-8 file as a PNG file. So this, if I save this file, I can actually open it, I believe, in the editor. Let me see. I'm going to save it right to carts as shooter. Now, okay, I'm going to save my stuff. Oops. What's this? Let's see if this works. Yep, load shooter. Oops, can't run there. So it's a really cool way to distribute your games. Kind of gives this like faux tangibility. You can hit F7 to choose the image that appears here. There's no text here, but I believe if the first two lines like are the title, maybe. Let's see if that works. So now I saved it. I look at folder. Yeah, I'm not sure if you guys can see, but this is the actual file. Yeah, it's rad. Yeah, so this is actually a really interesting tutorial. And next I'm gonna look at is how to do stuff like this. Oh, I guess if you highlight, oh, I see. Okay. So, reboot. Let's make like a player move around the screen. So I'm gonna draw like some sort of spaceship from the side. It's like a side view. Oh yeah, one thing I forgot to mention, you can use this sort of a bounding box tool and move things around. Kind of. Oh, actually, it's like, you know, actually, I don't know if you can do that. I was just moving. Oh, you can use the arrow keys. Let me get the hand back on. No, let's just use this one. So yeah, I'm going to draw like a basic little spaceship. Or try to. Okay, this is really terrible spread. This is the stupidest spaceship of all time. Let's just go with that for now. God, really? So now I have a player sprite. Build my update and draw functions. I'm going to draw the ship, which is sprite 3, to the screen at 6464, right in the middle of the screen. Yeah. Yeah. Let's do that. So let's make a character that takes up multiple sprites, and I'll show you how. So this is going to be pretty ugly, but let's do it. I'm basically trying to draw a big yellow circle. Okay. Beautiful. So this starts at sprite 4, and its width is 2, and its height is 2. So in the code, we can say sprite 4. Is that what it started at? Sprite 4 at 6464, width of 2 cells, height of 2 cells. So that. Oh, thanks. So that's how we draw our bigger sprite. To make the sprite move, it's going to do basically what you just did, Mark. Is we're going to check the buttons. So let's go with. Let me check the README real quick to see which button refers to which. So button 0 is left, button 1 is right, button 2 is up, 3 is down, 4 is button 1, 5 is button 2. So let's just go through them here. So here's where the concept of storing a player's values or using a table as an object comes into play. So I'm going to define a table called player. And I'm going to say player has an X value, say 64. Player has a Y value, 64. If button 0, that means we're hitting left. We want the X value of the player to go down, to move to the left. So we're going to subtract 1 from the player X value. So player X minus equals 1. Does that make sense to everybody? So far it's not going to reflect anything because we're not doing anything with player X or player Y yet. So we're going to do the same thing with right. If we're hitting the right button, player X goes up by 1 to move us rightward. I'm going to do the same thing for up. So if button 3, player's Y value goes down because Y values increase as you move down the screen, which is different in certain frameworks and always, I thought, counterintuitive compared to how you learn Cartesian coordinates in math class. And then if button 4, then player Y goes up by 1. Okay. Great. Now here's the fun part. In the draw function, instead of drawing at a hard-coded X and Y, we're going to draw at player X and player Y. One thing I'm going to do is change the amount we're increasing. Instead of having it be 1, I'm going to have it be 0.1, because otherwise there's only 128 pixels on the screen, so at 30 frames a second, 1 pixel, we're going to fly off the screen really quickly. Okay. Let's save this as face shooter. So now, as I hold left, okay, maybe 0.1 was a little slow, right? What's funny is, okay, so actually I mixed up button 3 and 4 because down is moving me up and up is doing nothing. Why? Yeah, good call. Let's change this. So yeah, we're updating our logic. We're setting all of our player variables here in update, and then we're just using them to draw stuff in the draw function. So now we can move around. One thing I like to do is add a little bit of physics to it. So I'm not sure how familiar you all are with physics, but basically you can do something instead of just adding 1 to your position. You can set a velocity variable, and then every frame add your velocity to your position, and then you can take it a step further and have an acceleration variable and add your acceleration variable to your velocity variable, and that gives it a lot more of a smooth, less of this kind of just chunky sort of really direct feel. So I'm going to do that real quick, and stop me if it's going too fast or is crazy. This is also going to open a whole lot of can of worms. So player, the way I define the player, you could do it this way, or I could also do it like this. Oops. Yeah, this is similar to creating a JavaScript object. So the player is a table with an x property of value 64, y64. I'm going to do xvel, and I could do velocity as a table, kind of a table in a table. But just for readability's sake right now, I'm going to call it xvel, have that be 0. So now in the update loop, every frame I'm going to say, hey, take player x, the x value of the player, and increase it by the player's x velocity. Same thing with the y value. And that means instead, when we hold buttons, we're not going to change the position directly. We're going to change the velocity of the player. So one important distinction here is we're not going to increase or decrease velocity. We're just going to set it to a variable, because every frame we're going to add this velocity to the position directly. So we just want to set it to 1 or any other variable. So now this is in essence going to have pretty much be the same thing, except one difference, which is the face can't stop now. Oh, I also forgot to make this -1. The reason it can't stop is because we're changing the velocity variable, but it's never getting reset. So at the beginning of every frame, we can just set the velocity to 0. So I mixed up these somehow. Does that make sense to everybody, kind of? Now, one cool thing I like to do is have, like, it seems like you should slow to a stop. You shouldn't just kind of stop in place like that. So I'm going to make a friction function. I'm going to show how, this is how you, an example how you can use a function outside of the built-in functions. I'm going to make a function called apply friction. So now that I've put it in there, I have to do the hard work of actually writing the function. I'm going to do a cheat here. So this is how you define a new function. Function apply function. Oops, not apply function, apply friction. And in this function, I'm just going to say every frame I want the player velocity to become 90% of itself. So every frame, if the velocity is not being set to 1, we're not holding a button, just gradually have it slow down on that curve. Let's see what that does. So it's coming to a stop very quickly. But you can see there's a little bit of a, you know, that is actually what's happening. Thank you. Maybe that was my, it must have been in my mind then. All right. I'm going to comment these out. Much better. That's what I expected. Okay. And we can take this a step further by having an acceleration variable. So player xvel. This is the same logic. We're gonna set an acceleration. So when you change directions, you don't instantly sort of change directions. You have to kind of give it a little sort of a give, kind of like when Mario's running fast one way and turns around, he skids for a bit. He doesn't just immediately go left. So basically, just going to copy exactly what I did, but add some new variables to our player object. So now we're fleshing out our player here, which is cool. Okay. So now I'm changing the input to affect our acceleration values rather than our velocity values. This is where things are going to get nasty because there's no limit on how we're going to keep adding to our velocity on this, and so our face is going to speed up exponentially and fly right off the screen. Let's see, because it'll be fun. Yeah. So the way to do that is to have a function called limit max speed. You know, let's just say if the player's x velocity is greater than 2, then make the player's x velocity 2. And there are cleaner ways to write this and fancier ways, but just for readability's sake, I'm just going to do this for all 4 of our dimensions. So if the player xvel, because we have to cover less than -2, so the max speed in the positive direction, and the max speed in the negative direction. Does it make sense to everyone what I'm doing? Or? Have to remember to run my limit max speed function here. And so by the end, I mean, ideally, your update and draw functions are just a list of functions you can find elsewhere. So now we have that cool, nice sort of give, but also can't go too fast. I'm going to do one more quick helper function while we're here, which is enforce boundaries, keep our player on the screen. So very similar. Basically going to say, oops, that's why you use the mouse. Always use the mouse. If our position is beyond the bounds of the screen at any time, you know what? Before I do this, there's one really cool function I forgot to show you guys. It's called camera. It basically automatically sets an offset to the screen. So let's have our face be able to move beyond the screen, have the camera follow. So I'm going to have this be called camera follow, and it's going to say camera X. No, camera. So the way we use the camera function is basically what is the center of the world the camera is looking at. So if I set camera to player X and player Y, that means the player is always going to be at the center of the screen. So let me make sure I put that in here instead of enforce boundaries. We're going to do camera follow. Now this isn't going to look like much now because since the player is already, well, it's not in the center, which is the origin point. Right now the face has a high velocity, like I'm hitting right, but nothing else is in this world. And the camera is locked to the player, so we can't tell. So let's fix that. I lost my beautiful map tiles from earlier. It's really too bad. I have an idea. I'm just going to do some basic stars right now. This is really not the best, but just want to get the point across here. So I'm going to draw the least ornate galaxy in the history of mankind. Okay, great. Now I'm going to draw the map using the map command that we did earlier. Just in one place, just have it always be at 0, 0 in the world. 0, 0 is the start point of our map. I don't know how many cells we did, but let's just do, you know, many. Let's just say as many as you got. Of course, I put the clear function again. Okay, so there's our stars. So now you can see we're moving around the world, but the camera is locked to us. I don't like how the oh, what was transparent? The yeah, the black. There's a way to fix that. I also don't like how the player's in the top left. That's really weird. So let's fix that too. Oh yeah, by the way, if you haven't figured out, Command F allows you to search your sketch. It's really nice. A lot of things you take for granted in Sublime, I find, are here. I mean, don't get crazy with multiple cursors or anything, but you know, it's a nice little editor they put together. Does that fix it? No. Let's the camera. Yeah. So I basically add an offset so the origin of the camera should be at the origin of the player minus half the screen. So now we've got this very boring space exploration game. Let's try making him fire hearts or something like that. I think that would be cool because he's bullets from a happy face. I don't know. I'll show you how to manage multiple objects. Does anyone have a question or anything you'd like me to talk about here, or is this too fast, too slow, too exciting, too boring? Why can't I draw this hard? I was doing so well. Okay, I have an idea. Yeah. Yes. Oh, could be worse. I am interested about that transparency though, because I know you can use black for transparency, but there's also pretty sure you can use black as a solid color too. Reset system. Okay. Set transparency for color index. Default, all colors opaque except color 0. So what I could do is set public transparency to a color I'm not going to use, or that I am going to use expressly for that purpose. So let's do that actually. T. Or just turn black off, I guess. Beginning of the sketch, I'm going to write Palt 0 false. Now we shouldn't have transparency anymore. Which actually is probably bad because the edge of the face is going to draw black, I think. You know what? Let's just stick with it. Okay, how much time we got? Let's fire some little hearts. So there's the heart. That is sprite 53. Say function fire heart. So what we are going to do is we're going to basically give the heart, each heart, its own velocity. We'll skip acceleration this time, and then add a new heart to a list of hearts. In every frame, run through the list of hearts and add and move each heart by adding each heart's velocity to each heart's position. So this is the pattern you're going to use for most everything in your game. So hearts equals an empty table, which we're going to use as a list, basically. So here you can see Lua tables operating both as an object and here as an array. So let's say when button 4 is pushed, and here we're going to use the button P function because we don't want a billion hearts to create when you hold fire. You want to have to hit it like you're playing Galaga or Space Invaders or something. So if button P4, then fire heart. Is that what I called the function? What do I call it? Uh-oh. I scrolled to oblivion. Fire heart, yes. If button P, then fire heart. I don't know. I'm just going. If you have any more inspired ideas, everybody, please. Fire heart. So how we're going to do this, it's nice to think of the update draw paradigm. So we're going to create a heart object with its position, its velocity, and then we're going to deal with rendering it in the draw function. Something happened? Everything okay? So here's how we create a new heart. We can use a local variable because we're just basically creating a prototype heart. We're going to put it in the heart array and then deal with them later. So local new heart equals an empty array, empty object, table. Let's say new heart. Now we want the new heart's new position to be where the player was because that's where it's being fired from. So New heart X equals player X. New heart Y equals player Y. New heart, let's say each heart is going to fire off. You know what? If this were a game where you fired hearts or bullets to the right, you could just set this to be 1s, because bullets always going to move directly to the right. But since we're kind of flying everywhere, let's have it fire in the velocity that the face is flying at that particular time. Okay, why not? All right, so there's our new heart we've created. Now we want to add this heart to the list of hearts. So add hearts. New heart. So what this means is add new hearts to the table hearts. So we're building a list of all active hearts in this empty list we've declared at the beginning. So now nothing's going to happen because hearts aren't being rendered. So now we're going to make a function called draw hearts. And what draw hearts is going to do, it's going to say for each heart in the hearts list, do this. We want to draw that heart sprite at each heart's X and each heart's Y. So the heart is sprite 53. Draw sprite 53 at the heart X and the heart Y. There's one thing we didn't do, which is update the heart's position every frame based on the heart's velocity. So I'm going to make a function called move hearts. And it's going to be very similar. For each heart, increase that heart's X value by that heart's velocity, X velocity value. Now I'm going to add these functions to our update and draw loops. So, what was it? Move hearts. Move hearts, and the draw function. I'm going to put it above the map, because we want it to be above the background, but below the player. So it kind of comes out from under the player. And you can fuss with offset and stuff. So usually you wouldn't fire such a large sprite, but we're getting wild, so it won't matter. Let's see. Draw hearts. Okay, that should work. But it doesn't. Did anyone spot what I did wrong this time? No. I don't know. Fire. Oh, it's. No. Fire heart is button 4. I don't think I am. Nope, I am. Yeah. Add hearts. Draw hearts. Heart X, heart Y. So here's a time where we can do a little debugging. So I'm wondering if maybe the hearts aren't even being fired. Is button... I think I might have messed the button number again. 0, 1, 2, 3, 4. So button 4 should be C.
Oh wait. Oh, I think you did.
Yeah?
You call the variable new underscore heart, but then you add new heart without underscore.
Round of applause. Thank you. I think it was... It's surprising it didn't throw an error. Yeah, or add a null, add just... So what's happening here is actually the heart is traveling at the same speed as the player. So the hearts are kind of just sitting. Let's make the heart velocity. Ooh, this is tricky because if we just add 2 to x value or y velocity, we don't know which direction. So we don't know if xvel and yvel are positive or not. So, I mean, we could do some. We could check the sign. So like, brilliant. So, what did you say? Yes, yes. So we could do a little hacky conditional here. And you can do things like and or, something we haven't seen yet. Sorry? So, I mean, this is where we would probably want to design this better. But it's interesting. I'm showing, I mean, hopefully it's interesting. This is kind of how you would iterate and how you would mess around with creating dynamic objects. Then, let's say if either dimension is 0, let's just set xvel to 2, like just splatter to the right. You can do a else is another conditional. That makes familiar conditional. Okay, so that hopefully will. Okay, so now the hearts are coming out fast and furious. And actually, the friction. I don't know why the friction command is not working, because we should be stopping, right? Did I get rid of that? Slow down a lot faster. Another command that's interesting or useful is Command G. Once you have a search going, it'll find the next instance, or it should. Order these things might be a little. Oh, I broke our friction function somehow. don't know why. But yeah, so that's how you would manage creating multiple objects on the fly and giving them properties. You'd probably want to do something like when they're off screen, delete them from the list, obviously, otherwise you'll accumulate a list of 4,000 hearts. I'll show you how to like detect collisions, which is a little arduous because you have to basically do it how you think you would do it, which is cycle through lists, compare their positions, and not just their positions, but account for each item's width and height. So I'll do that real quick, and then we'll move on. I'll show you some like export options and anything you guys want to look at. Anyone have a question, or is this going okay? Let's do in the update function. I'm going to do well, we don't have anything to collide against. Let's make some enemies, why don't we, or something. Okay. What do you want as our enemy? So I'm going to create a bunch of random enemies on screen. Since we're kind of running out of time, I'm going to move a little fast here. So just yell at me if it's not going, if you're not following, or if I'm making a blatant mistake, which is possible. Let's see. So at the beginning, we're gonna create a bunch of enemies. Just randomly create enemies. Function create enemies. I'm going to go through a loop. Let's say 15 enemies, just to start. I'm going to create, just like we did for the hearts, a local new enemy. It's an empty table. Say local, the new enemy is going to have an X value that's a random position between 0 and 200. And a new Y value that's random between 0 and 200. We're also going to do a draw enemies. And so when you make this, you usually plan on have more abstract functions. So move thing, draw thing, so you don't have to have a function for every type. But just for now, we're also going to add the new enemy to the enemies array, which I haven't made, but I will. Let's draw enemies. So let's see. For enemy in all enemies, do consult enemy is sprite 51. Draw sprite 51 at the enemy's X and the enemy's Y. I'm not going to give them velocity or anything right now. They're not going to do anything. They're just going to sit there like sitting ducks. So I must have spelled that wrong. Create TT enemies. This is where that font can really mess with you. This function doesn't exist. Line 17. Again? The other one? Is there an extra E? Maybe I can't run it in this. It may have to be in the init function rather than just sitting out in the wild. Okay. Where are our enemies though? Did I not? I don't think I called draw enemies in the draw loop. Okay, we're gonna draw. Just as a test, I'm going to create all the enemies right where the player is, so we make sure the camera is looking at them. Okay, that's clearly not working. Oh, you know, I don't think I even created enemies list. Remember when I said I was going to do that earlier and then didn't? Okay, beautiful. Let's turn that transparency back to true for now. And go back to create enemies and have them randomly between 0 and 200 on both axes. Okay, there they are. Now the tricky part, the collision detection. Function check collisions. So what's what we're going to do? We're going to create a loop. We're going to say, for every heart in the hearts array, loop through every enemy in the enemies array. This is the part that's really going to look ugly. So usually, as you build out, you'll find more efficient ways, like each object should maybe have a width and a height stored or something like that. But for now, I'm going to say if heart X is greater than enemy X and heart X is less than enemy X plus 8, which is the hard-coded width of the enemy. This is what would be dynamic. And heart Y is greater than enemy.y, and heart Y is less than enemy.y plus 8. Then, so this is a real quick and dirty, just compare and make sure that actually it should be, we're going to compare you could probably do this smarter with like a circle and radius, or you could, I'm wondering, because this will check the top left of the heart sprite, not the center. Okay, this is going to be janky, but we're going to just see if it works for now. If that happens, delete the enemy from the enemies array. It will cease to be updated, it will cease to be drawn. Here's where the tabbing really comes in handy, because when you have all these loops and if statements inside of each other, so So I don't know. Actually, I'm not calling that function yet. Check collisions should be put in the update function. So as you can see, it's kind of working. Yeah, so there are better ways to do it. There are ones that involve a lot more ugly code, and then there are prettier ways. But this is the general approach you take to doing something like this. Does anyone have any questions or ideas or? Another basic thing you might do in a game is like use just a global like phase variable. Be like, let's call it game phase. So if game phase, so in the draw loop, you could do something like, there's no switch statement, but basically what I'm saying is if game phase is 0, you're at the title screen. Then only draw the title screen. Then else if game phase is 1, then actually draw the game. And you can do a similar thing in the update loop to give different phases of the game different functions for different buttons. So in the update loop, I'd say if game phase is 0, if button 1 is pushed, make game phase 1. So this is how you like move from different screens, different parts in the game. I'm not going to complete this though. So maybe I'll move on to showing you how to like export sketches and like some of the options there. So here's what's really rad about PICO-8. Man, export appears a lot in here. So actually, you were asking earlier about importing sprite sheets. You can use the import command to actually plop in palettes from other games. That's what I should have done, is loaded my nice sprites from a game I've actually done before. Let's see if that works. Let me, importable formats. What does that mean? Oh, okay. It's because there's two of the same name here. So I'm just going to bump this up. It's the cards directory. Import. Okay, maybe I can't figure this out. Well, what we can do though is export. So I just exported a sprite sheet of all of our beautiful, beautiful work in this this test sketch. But more interesting than that, and exporting our music, is generating a standalone HTML player. So if you just want a one-stop sort of thing, export our sketch.html creates our sketch.js and our sketch.html. So now in the folder you'll see these new files. Our sketch.html has the PICO-8 player. It's got the controls for pausing, full screen, sounds, and it's totally playable with audio and web. I think it's pretty cool. And you could just export the JS file because the HTML that comes out it's just a basic, you know, some inline style, and like, wow, actually this is a lot more than I thought, and some looks like some really thoughtful web-specific key handlers. God, there's a lot in here. Oh, this is the Chrome for the like pause buttons and stuff. What I think is cool that I haven't done yet, which is kind of new, with this P flag, you can basically create your own template, and then with using this tag JS file to kind of include it wherever you want. You can also, one thing I didn't talk about is you can do cool things like add custom menu items. So let's just take this example. Running our, it's just one, run one of our random sketches from earlier. This menu items might only exist in the Splore interface, but basically you can add menu items to the standard reset cards and options like that. But I want to get back to exporting different versions. Okay, here we go. Binary player. So this is also something new that I wasn't aware of. Let's load up one of our other sketches, like lines that made no sense. I'm going to now export lines.bin. So this will use the cartridge label as an icon and basically create either a Mac OS X, Linux, or Windows executable. Okay, no icon found. Let's create a label. So I believe F7 is how to create a label. On Mac, you're going to have to hold function key while you do it. So now we have a label image. Now, one cool thing, you can hit up arrow just like a regular command prompt to see items in your history. Export lines. So now we have this lines binary folder that has a Mac app with the icon we chose, a Windows app, Linux app. You run it, there it is. There's our compiled Mac app. I think you can do, it has full screen built in. There might be a flag you can send to default to full screen, which I think would be cool. So I mean, as you can see, for such a sort of esoteric tool, it has a lot of nice real-world functionality and makes it really easy and versatile to distribute anywhere. Oh, so here's where you'd be able to add a custom menu item to this menu. I've never done that, so let's try it. I'm just curious. Let's grab that. Paste what they put. Oh, here's an anonymous function. Function SFX. Let's have it do nothing, actually. Do nothing. Does that run? Did I break it? Okay, now I'm going to export again. We have our new Mac app. What? So now we have our nice custom menu item that does nothing. So yeah, that's pretty much all I've got on this introductory syllabus here. Is there anything you guys wanted to talk about or explore? Like, if I don't know the answer, we can look into it together. Yeah. Yeah. Mark mentioned this earlier. So the way you would do it would be kind of, again, like the way you probably think you would do it. So you would have you basically would draw your different frames in different locations. So you could copy and paste. I don't know what I'm drawing, by the way. Yeah. So you would have an object. Let me load up a different sketch. Let's see what the enemies are. Yeah. Yeah. So basically, you'd have multiple sprites, and then you'd have a variable in your player object, your enemy object, called frame. And then you'd increase it every frame or every 4 frames, and then switch in the draw function which sprite you're outputting. Yeah, that's the thing you should think about whenever you're doing anything with this. Yeah, which is actually nice, because then you have total understanding and total control, and you worry less about being sloppy or inefficient, because you're probably doing it like, okay, well, let's not get crazy, but you know what I mean. It's you're not missing some grand shortcut. If it's not in the README, there probably are examples, there probably are better ways to do it, but that's how you do it. Yeah, let's look at the saxophone, actually. I have it here. Let's see what's going on there. So yeah, you can do that. When I last made a game with this, I didn't, because it was an alpha and kept crashing. But yeah, but apparently on that GitHub I linked to earlier, let's see. There's a lot of good resources here, including like Sublime plugin. So I mean, what's that? Yeah, yeah. So this might be it might be a lot easier to do it that way. Yeah, in a big project, or to dissect someone else's. I'm scared of it because of the crashing issue. I used to save compulsively, but yeah, I think there's a way to So it looks like when you edit a cart externally, you have to reload in PICO-8 with Control R. Yeah, so that's the only foible. It looks like people are requesting better text editor support. Yeah, you can, and the graphic data will be at the bottom of the file. It's kind of cool to look through it. So that you can actually yeah. So you can take the sprite sheet from another cartridge, or there are probably easier ways to do that. But yeah, you can see the nuts and bolts here. I'll give it a little show right here. So like if you look at our lines that made no sense, P8 file. I don't know why it does this. Like here's what the file looks like in Sublime. I think let's see, Lua. Oh, I have a Lua syntax highlighting, but I think there's a PICO-8 highlighting you could get. And here, this is actually how the graphics data is stored. You can see most of our banks are completely empty. We only have a few sprites in there. Same thing with map data and SFX. Yeah. So you can edit here, and then just in PICO-8, hit Control R. Is this what I have loaded up? Let's see if it works. Yeah, so let's see. Let's get rid of CLS here. Load lines. Makes sense. Okay, there we go. Interesting effect. Yeah, that's what the change I made here, and then just to save external editor. So I'd save here. Yeah, Apple Art said load external changes, so it's pretty smart with that kind of thing. Yeah. Yeah. Here, I'll show you the. So this is a sprite sheet of a game I did to show you that I actually can draw a decent sprite. Look at this. Floppy disk, treasure chest, crazy large planet. Oh, this one's really, I'm proud of this one. Different, oh, yeah, this is how I did the construction blocks I made too. Gas can, pink orb, med kit, space ram. You want to see the game? Sure. Yes, I can. So it's like a little 4 or 5 level 15-minute space exploration game. So I use the technique for the camera locking the player technique that I showed you with the smiley face game. So things like this, it's really fun just to layer on the details, like have each letter appear with a little tick sound effect. No, I sent the sketch to a composer I worked with, Mark DiNardo, and he basically sent the file back. Yeah. So it's kind of I wrote like a faux physics where you thrust this little spaceship around and explore these worlds. So there's all sorts of little. If you crash into walls too roughly, you lose life, which is an H, the health bar. This is a cannon you can kind of get. Yeah, the music starts playing when you're in danger of dying. And so to beat each level, you just gotta find the land pad and land on it safely. So I'm drawing a section of the map in the background, and then a section of the map in the foreground, and moving around the player with velocity, acceleration, and having the camera follow him. So we've got to get the key. I want this little. Okay, so there's some animation actually on the pylons that are lit up, just alternating between 3 frames per object. The collision detection was really hard. You use the flags. I basically have certain tiles set to certain flags, and I'm checking the if you collide with a tile, then check its flag. This is my favorite one. So you find the floppy disk and your gas tank. This is using the P set, just kind of creating these little particles that have their own basic gravity that's supposed to look like your fuel tank is leaking. So you've got to really hurry through this one. Uh-oh. My energy is There's only 5, I think. Might be 4. So, it's hard to say because I was so inspired by PICO-8. Every night after work, I just cranked it open and worked on this every night after work for 3 months, maybe 2-3 months, learning along the way. And it also had a lot fewer features back then, so it's hard to say. But it was a blast, and the constraints were actually liberating in a a way to be able to say I'm not that good at art, but I can really like spend some time on a few 8x8 sprites and have fun with it. Same thing with the level design. Like I had limited map data, so I'll show you what the map data looks like here. I'll lose my progress though, but it's okay. You can get to the end on your own. So as you can see, I basically fit in the levels next to each other. So here's level 1. Here's level 2 with that kind of spiral, finding the floppy disk. Level 3, that's level 2. Here's the level I didn't beat. And here's the final level, which is the most massive level, which is really fun. So you can see I use the sprite sheets here. These are some title screen graphics, some burgers of varying sizes, Coke can. And the map data, I use the second half of my sprite banks for map data, and this is what it looks like. Yeah. So, yeah, definitely, if you guys want to mess with the machines over there, or if you wrote anything you want to, like, run with a gamepad, I have a few Nintendo gamepads. Otherwise, I hope you continue to mess with it, because it's a really fun, surprisingly powerful platform. Sure, thanks for coming.